Okay, let's take a look at the solutions to 2025 AP Calculus Free Response question number 6. This was an implicitly defined curve, and we were asked to do a couple things with it. First and foremost, part A, love this question when we get this, right? I always tell my students, anytime you're basically asked to prove something that they're giving you the answer to, you want to take advantage of that. And that's what they're doing in part A. So part A asks us to just show that the derivative of this dy dx is equal to something specific. So we're just going to go ahead and prove that right now. So implicitly defined, we have 3y squared dy dx minus 2y dy dx minus dy dx plus 1/2 x equals 0. So all that's left to do at this point is the algebra, just getting all the dy dx's together, right? So we're going to say dy dx times the quantity of 3y squared minus 2y minus 1 is equal to negative 1/2 x, or x over 2. And so all we got to do to finish up here is prove algebraically that we are looking at that. And that is exactly what they wanted us to prove. So there's part A. Okay. Part B now is going to ask us to use this in tandem to find some other things, right? So part B says there's a point P on the curve G, which is defined by that implicit equation right there. So there's a point P on the curve near to -1 with x coordinate 1.6. Use the line tangent to the curve at 2, -1 to approximate the y coordinate of point P, right? So first things first, let's go find, this is part B, let's go find what the derivative is at 2, -1. And when we do that, when we place 2 in for x and -1 in for y, we wind up getting -1/4. So tangent line equation, right, would be y plus 1 equals -1/4 x minus 2. And all they want us to do is use that tangent line to approximate the value of 1.6. And so all we'll do here is, well, we can say y of 1.6 would be approximately -1/4 times -0.4. That's what happens when we put 1.6 in there. Take away 1. And that will give us a nice clean -9/10, or -0.9. Okay, shifting gears to part C now. All right, part C says for x and y both greater than 0, there's a point S on this curve where the line tangent to the curve is vertical. And they want to know the y coordinate of that point, right? So where would the tangent line be vertical? Well, it would have to be where the bottom, right, where this function right here, where this quadratic is equal to 0. So that's our first order of business, is let's figure out where this is equal to 0. There we go, right? Now remember, they had said earlier in the problem that x and y are both bigger than 0. And so that would take out any value we get there. And so the only y value we need to consider would be y equals 1, and that's it. For part D, question says a particle moves along curve H defined by the equation 2xy plus ln of y equals 8. And they say at the point 4, 1, it's known that dx dt is equal to 3. So this is like an implicitly defined problem with respect to time, so related rates kind of situation. So they'd like to find dy dt at this instant, right? So another implicit problem. Here we go, right? Plus 1/y dy dt, don't forget equals 0, right? And then now it's just a matter of plugging in x, y, and dx dt. And when we do all that, we should find that dy dt at this point equals -2/3. So that is 2025 AB6. That takes care of video solutions for the AB problems. Look for solutions to the specific BC problems as well. Thanks for watching.